Hello students, welcome back. I hope that you are following the concept thoroughly. We discussed about the concept of close packed structures, hexagonal close packing and cubical close packing, and then we discussed about the concept of tetrahedral and octahedral voids, and then we also discussed about the packing fraction or packing efficiency. Now I would like to ask you a question. Have you wondered any day that how the sodium and chloride ions are arranged in NaCl crystal lattice, and likewise how zinc and sulfide ions are arranged in zinc sulfide crystal lattice? So to know about the structures of these common ionic compounds, let's start the presentation then. So students, in this part we are going to learn about the structures of some ionic compounds. So we will discuss about the structure of some very common ionic compounds which are very important for JEE point of view. So let's start. So here I classified the structure of ionic compounds into 5 types. I divided, one is AB type, other is AB2 type, and the third one is A2B type, the fourth one is spinel structure, and fifth one is perovskite structure, and we also have one more, that is corundum structure. So we have 6 different types of structures we have. So in this presentation, in this video I'll discuss only about AB type and AB2 type. So the rest 4 I'll discuss in my next part. So AB type, so under AB type we'll discuss sodium chloride structure, cesium chloride structure, zinc sulfide structure. Under AB2 type we'll discuss only calcium fluoride structure, because all these 3 also have the similar structure as of calcium fluoride. So let's start with the AB type structure. So under AB type we have the one which is very important, that is NaCl, sodium chloride, which is also known as rock salt. So let's study about the structure of sodium chloride, how the sodium ions and chloride ions are arranged, and what is the coordination number and coordination number of cation as well as anion, and also the number of sodium ions per unit cell and the number of chloride ions per unit cell. So all these details we will discuss. Yeah, it is composed of positively charged sodium ions and negatively charged chloride ions. Yeah, this is the structure of NaCl. So here let's see the arrangement of chloride ions. So chloride ions are present at the center, at the corners as well as the center of each face of the cube. So the chloride ions are present at the corners as well as at the face center. So this arrangement is also regarded as FCC type of arrangement, which is a face centered cubic arrangement. We already know what is face centered cubic arrangement. We already discussed this. So the chloride ions are present at the face centers, at the face centers as well as the corners. Yeah, what about the sodium ions? The sodium ions are present in all the octahedral holes or all the octahedral voids. So we know that we already located the octahedral holes, that is edge centers. So all edge centers we have octahedral voids, as well as at the center of the cube we have one more octahedral void. So the sodium ions are going to fit into these octahedral voids, and the important thing is to remember here is all the octahedral voids are occupied. Not some, but all the octahedral voids are occupied by the sodium ions. So here there are 6 octahedral holes. So there are 6 octahedral holes around each chloride ion. So which I'll show you in this image. So here the sodium, in this picture, through this picture we can understand the coordination number of sodium ion as well as chloride ion. So we already know what is the coordination number. The coordination number is number of nearest neighbors of a particular ion. So if you take the sodium ion is what? The sodium ion is this one, which is shown in this color, this one. So if you see, this is surrounded by 6 chloride ions. The chloride ions are shown in this blue color and it is shown in some gray color. So here each sodium ion is surrounded by 6 chloride ions, right? So these 2 chloride ions belongs to the neighboring unit cells, but all the other 4 are belongs to this particular unit cell. So each sodium ion is surrounded by 6, as well as each chloride ion is also surrounded by 6 sodium ions. So you can see here, which is at the corner, this chloride ion. So this chloride ion is surrounded by total 6, right? So 1, 2, 3, 4, 5, 6. So each chloride ion is also surrounded by 6 sodium ions. So the coordination number of chloride ion is also 6. So here it is 6:6 coordination. So each ion is surrounded by 6 other ions. So let's calculate the number of sodium ions per unit cell. So we know that the sodium ions are present in octahedral voids. So octahedral voids are present at the edge centers. So total we have 12 edges, and so each edge center is shared by 4 unit cells equally. So the contribution is 1 by 4. So 12 into 1 by 4. This is the contribution from the edge centers, and we have one more at the body center. So total we have 4 sodium ions. Okay, so we have 4 sodium ions per unit cell, and let's calculate the number of chloride ions per unit cell. So the number of chloride ions are at the corners plus at the face centers. So we have total 4. So here we have 4 sodium ions as well as 4 chloride ions. So the number of NaCl units per unit cell is what? 4. So we have the number of NaCl units or formula units per unit cell is 4. Okay, so that is 4 sodium ions as well as 4 chloride ions. So this is about the structure of sodium and chloride ions. And one more thing which we have to know here is, so how these ions are touching each other. So if I take along one particular edge, so this is a chloride ion, and this is one more chloride ion have at other corner of a particular edge. So 2 chloride ions I am taking, and one sodium ion is present at the edge center, right? So this is Na plus, and this is Cl minus. So here, from here to here, the center of chloride ion to chloride ion, this distance is A. That is the edge length, right? So the radius of sodium ion plus the radius of chloride ion is equals to what? This is the radius of chloride ion, this is the radius of sodium ion. So which is exactly half of the edge cell length. So this is the relation that you have to remember. So in exams the question will ask like this. So they'll give the edge length, they'll give you one of the radius, and they'll ask you to calculate the radius of other ion. Okay, so like that. So let's move to the structure of cesium chloride, which is simpler as compared to NaCl. So let's see the structure of cesium chloride. So here what we need to understand is how the chloride ions as well as the cesium ions are arranged in a particular unit cell. The chloride ions are present at the corners of the cube. So Cl minus at the corner of the cube, and the cesium ion, which is bigger in size, is present at the center of the cube, right? So this is the blue one is actually cesium. The blue one is actually cesium, and the red one is actually chloride. So the cesium ion is present at the center of the cube, and chloride ions are present at the corners of the cube. Yeah, you can say this is the space filling model, where this orange one is actually touching all the other chloride ions. So this cation, that is cesium ion, is touching the chloride ions which are present at the corners of the unit cell. Yeah, the unit cell of cesium chloride has one cesium ion and one chloride ion. So one cesium ion, because we have only one ion at the center of the cube, so the contribution is 1. And here we have 8 chloride ions. Into 1 by 8 we will get 1 chloride. So the total we have, the number of chloride ions are 1 and the number of cesium ions are also 1. So there are only 1 cesium chloride formula unit per unit cell. Okay, so before NaCl we have 4 formula units in a given unit cell, but here we have only 1 formula unit of cesium chloride per unit cell. So one more thing which you need to understand here is how the atoms are touching, how the ions are touching each other. So they are touching along the body diagonal, right? So this is the body diagonal which is shown here. So the cesium ion is touching this ion and is also touching the other one, which is exactly opposite side of this cesium ion. So here the relation between the cation and anion, the radius of cation and anion, which I will show in my next slide, but one which you need to understand is they touch along the cation and anion, they touch along the body diagonal, right? So the next thing is the coordination number. The coordination number of cesium and coordination number of chloride. So here the cesium ion which is present at the center is touching with 8 chloride ions. So the coordination number of cesium is undoubtedly 8, and similarly the chloride ion which is present at the corner, let's say this is the chloride ion which is present at the corner, which is surrounded by 8 cesium ions, right? So you can see the green ones are cesium, and the white ones are chloride ions. So each chloride ion is surrounded by 8 cesium ions, and each cesium ion is also surrounded by 8 chloride ions. So it's a 8:8 coordination. The coordination number of cation and anion equal, and that is equals to 8. So the relation between the radius of cation and the radius of anion and edge length is given by this one. Okay, so which you can easily understand, because since they are touching along the body diagonal, so 2 into the radius of cesium ion plus the radius of chloride ion is equals to root 3a, which is the body diagonal length. So yeah, this is the expression which is shown here. Okay, so this is very important for solving numericals based on the cesium chloride structure. So other common examples of this type of structure are cesium bromide, cesium iodide, where the cation should be bigger in size as compared to anion. Okay, so next is zinc sulfide, which is the other important structure which is very commonly asked in exams. Zinc sulfide. Here zinc sulfide has 2 forms. So first we'll discuss the sphelerite structure, and then we'll go to wood-joint structure. So first is sphelerite. Yeah, this is a more or less very easy structure as compared to the other one. So now see the arrangement of sodium sulfide ions. The sulfide ions are arranged in CCP arrangement. So CCP is nothing but FCC. So the sulfide ions are present at the corners as well as at the face centers, which are shown here. So the yellow ones are sulfide ions. Which are bigger in size. So which are present at the corner as well as at the face center. So let's see how the zinc ions are arranged. So always remember, the lattice is formed by the bigger ions, those are anions, and cations being smaller in size, they occupy the voids, either tetrahedral or octahedral, partially or completely. So let's see here. The zinc ions, they occupy the tetrahedral holes here. So per unit cell you have total in this CCP arrangement you are going to have 8, right? Because there are 4 atoms, there are 4 sulfide ions are there. So each sulfide ion has 2 octahedral voids. So it has totally 8 octahedral voids. So out of 8, only 4 are going to be occupied by zinc ions. So only half of the tetrahedral holes are occupied by zinc ions. So which are alternating. So the zinc ions, they occupy the alternate voids. See here it is this tetrahedral void is occupied, and leaving this is occupied, this is occupied, right? So out of 8, only 4 will be occupied by the zinc ions. So let's calculate the coordination number. Let's do the coordination number as well as the number of zinc and sulfide ions per unit cell. So these are the things which you need to calculate and remember for each structure, the coordination number as well as the number of formula units per unit cell. So each zinc ion, this yellow one is a zinc ion. So each zinc ion is surrounded by, now yellow one is actually sulfide, which is bigger in size, right? So each sulfide ion is tetrahedrally surrounded by 4 zinc ions, right? And each zinc ion, say this is the zinc ion, so zinc ion is also surrounded by 4 sulfide ions. So it is a 4:4 coordination, and let's calculate the zinc ions as well as the sulfide ions per unit cell. So the number of sulfide ions, so sulfide ions are present in FCC arrangement. So the number of sulfide ions will be undoubtedly 4, and the number of zinc ions will be 4, because so we have total 8 tetrahedral voids, but out of 8 only half are occupied, that means only 4 are occupied. So we have the number of zinc ions equals to 4, So total there are 4 zinc sulfide formula units per unit cell in case of sphelerite structure. So this is about the structure of zinc sulfide, that is sphelerite. So let's move to the other form of zinc sulfide, that is woodsite. So it is which is an alternative form in which the zinc sulfide occurs in nature. So here it is a more or less a complex arrangement of zinc and sulfide ions as compared to the sphelerite structure. So here the sulfide ions have HCP arrangement, hexagonal close packing arrangement. So you already know, we already discussed about HCP arrangement. So which the sulfide ions will occupy the corners of the hexagon as well as the face center of the two opposite faces, and there are 3 will be present completely inside the HCP unit cell. So the sulfide ions have HCP arrangement, but before in sphelerite they have FCC arrangement. So the zinc ions occupy the tetrahedral voids, but here also only half of the tetrahedral voids are occupied by zinc ions, which are shown in this picture. The coordination number of both ions are 4. Now let's calculate the number of zinc ions per unit cell. Number of zinc ions. So zinc ions are nothing but half of the number of tetrahedral voids. So there are 4 within the unit cell and there are 6 at the edge centers into 1 by 3. So you will get total 6. The number of zinc ions per unit cell you will get 6. And the number of sulfide ions which are occupying HCP, so 12 at the corners, and we have 2 at the face centers, and we have 3 which belongs completely to the unit cell. So this value if we calculate, it also comes out to be 6. So here the only difference there and here is, here the arrangement of sulfide ions are HCP rather than CCP, and there are 6 zinc sulfide formula units are there in a unit cell. Okay, so this is about the woodsite structure, which is alternative form of zinc sulfide. So other is AB2 type. So till now we have discussed AB type. So now we are going to discuss about AB2 type. So AB2 type is also known as fluoride structure. Fluoride structure or AB2 structure. Fluoride. Here the calcium ions are arranged in CCP arrangement. That is, they are present at the corners as well as at the face centers of each face, and the fluoride ions occupy all the tetrahedral holes or all the tetrahedral voids. So here the blue ones are tetrahedral voids and the red ones are calcium ions. So calcium ions are present at the corners as well as at the face centers, and the fluoride ions are present in the tetrahedral holes or tetrahedral voids. Okay. So here the number of calcium ions will be only 4. We have only 4 calcium ions, but we have total 8 fluoride ions. So we have total 8 fluoride ions. So the coordination number of calcium is 8, because if you see the calcium ion, so the calcium ion is which is present at this face center, which is occupied by 8 fluoride ions. So the coordination number of calcium ion is 8, but the coordination number of fluoride is only 4, because the fluoride ion which is present at in this tetrahedral hole is only tetrahedrali surrounded by 4 calcium ions. So the coordination number of F minus is only 4, and we have each unit cell contains 4 calcium ions and 8 fluoride ions, which the number of calcium ions are 4, but the fluoride ions are 8. Okay. So this is about the structure of calcium fluoride and sodium chloride and cesium chloride as well as zinc sulfide, which is one is sphelerite and other is woodsite. So in our next video we will discuss about the remaining structures of the ionic compounds which are left out. While studying this chapter, if you get any doubts, you can post it for free on askIITians.com. How? First open the website, and if you see at the top right, you will see a discussion board. So simply click on that. It will take you to the next screen. In the next screen, you will see the Ask Experts, a separate section on the right hand side. So select a relevant category for your question and simply post your question here. We experts at askIITians will provide answers to your questions within 24 to 48 hours. So students, in this part, we discussed about the structure of some ionic compounds of AB type. We discussed about the structure of sodium chloride, and we have seen how the sodium and chloride atoms are arranged, and then we also discussed about the structure of cesium chloride and zinc sulfide as well. In that, we discussed about the coordination number of cations and anions and the number of formula units belongs to each unit cell in the structures of type AB. In our next part, we'll discuss more about some other structures like AB2 and spinal, corundum, all these structures.